Hello, so these are the notes for Wednesday, March 24th and Thursday, March 25th. You only have two sections tonight, which are 6.R.1 and 2.5. All right, so let's get started. So tonight we're going to talk about rational expressions. We're going to determine any restrictions on the variable in a rational expression. We're going to evaluate rational expressions for given values of the variable, and we're going to reduce rational expressions to the lowest terms. So the first thing we're going to do is talk about restrictions. So if you have any number divided by 0, if you plug this in your calculator, if you typed in 5 divided by 0, your calculator would tell you you made an error. Because if you have a denominator of 0, that means your answer is undefined. Even your calculator doesn't understand this problem. So that means that the denominator of any expression can never be 0. So when it asks about restrictions, the first thing you want to do is figure out what value would x be that would make the value of the denominator 0. So basically, you're going to take what's in the denominator and you're going to set it equal to 0 to figure out the only value that x cannot be. So when I set this expression equal to 0, I want to solve for x. So to get rid of -1, I'm going to add 1 to both sides of the equal sign. So I have 2x is equal to 1. And then when I divide both sides by 2, even though it says x is equal to 1/2, that actually means that x is not allowed to be equal to 1/2, because if it were 1/2, my denominator would be a 0, which I'm not allowed to have. So my restriction is that x cannot equal 1/2. So once I solve the expression, if I end up with a final answer of x is 1/2, when I look at my restrictions, I would actually say that it's not allowed to be 1/2, and therefore there are no solutions. All right, so let me get rid of some of this. Actually, yeah, let me just see what the rest of the directions say. So the restriction is that x is not allowed to be 1/2. All right, and then I'm going to answer the rest of the question. So it says, determine what values, if any, will make the rational expression undefined. Okay, so that's all we had to do on this particular problem. All right, so before I simplify this expression, the first thing I want to do is find the restrictions. So that means when you find the restrictions, all you're going to do is take your denominator, set it equal to 0. Now, obviously, we did these kind of problems in our last unit. These are quadratic equations. So we wanted to think of two numbers that multiply to give me -3 and add to give me -2. So that would be -3 and +1. And since it's equal to 0, that means we're going to take both expressions. We're going to set them equal to 0. So m cannot be either -1 or +3. These are our restrictions. So m cannot be either of those answers, right? So then once we've figured out what our restrictions are, now we can simplify the numerator. Well, this is the difference of two squares. So I'm going to find the square root of m and the square root of 4. One gets a plus, one gets a minus. So I simplify the numerator. Now I know that the denominator, I've already simplified this, is m -3 and m + 1. So now when I'm trying to figure out what this, actually, it doesn't even ask me to simplify it. But anyway, even if it did ask me to simplify it, I can see that nothing simplifies. I can't reduce anything. This one only asked me to figure out what the restrictions are. However, as we go forward, the directions will be to simplify the expression, and this one doesn't simplify. So this is the final answer, simplified, and these are the restrictions. All right, let's see what this one says. This one says, determine what values of the variable, if any, will make the rational expression undefined. So this does not tell me to simplify. I need to pay attention to the directions. So we want to see what would make the denominator equal to 0. So we would have x squared plus 36 is equal to 0. Well, this can't simplify because if you have the sum of perfect squares, it doesn't simplify, right? So let's see, can I subtract 36 from both sides? If I did, I end up with this. So there are no restrictions on this one. Because if I try to find the square root of both sides, this is an undefined answer. So there are no restrictions on this particular problem. And one of the reasons I know that is that this cannot be factored unless I use the quadratic formula, where b is 0. No. So there are no restrictions. There's no number that x can equal to make the denominator equal 0. Because even if x were -6, -6 squared is positive 36. So there are no restrictions on this particular problem. All right, then it says find the value of each rational expression for the given value of the variable. So they give us an expression, but then they also tell us what x equals. So we're going to multiply 2 times 2, because x is 2, and then we're going to plug in 2 for x plus 1. So 2 times 2 is 4, 2 squared is 4, and 4 plus 1 is 5. So all we're doing on this particular problem is substituting. That's it. All right, here it tells us to find the value of each rational expression for the given variable. All right, so a is 3, so we're going to do 3 minus 3 over 3 squared minus 5. So we have 0 divided by 9 minus 5 is 4. And 0 divided by anything is 0. So you guys are going to be doing some of those substitution problems. All right, so on these 3 examples, we're going to first find the restrictions, then we're going to simplify the expressions. So when we find the restrictions, all we care about is the denominator. So we're going to have 5x minus 15 is equal to 0. We want to solve for x, so we would add 15 to both sides. So we'd have 5x is equal to 15. And then finally, when we divide by 5, we find out that x is equal to 3. And when it's a restriction, it's actually saying that x is not allowed to equal 3. Okay, so let me get rid of this and then I can simplify. But we need to remember our restriction is x is not allowed to equal 3. Okay, so we're going to come up with, on the numerator, we can factor out a 2. So I'm going to factor out a 2. So I get x minus 3, right? And then on the bottom, or the denominator, I'm going to factor out a 5. So I have x minus 3. And then I see that x minus 3 cancels out, x minus 3. And I end up with an answer of 2/5, which I'm allowed to have because this is my only restriction. All right, let's look at the next one. So my denominator, my restrictions, I'm only worried about the denominator. Well, this is the difference of squares. This is the difference of squares. So I know I can simplify this by finding the square root of x squared, square root of 25. One gets a plus and one gets a minus. Now we're going to set them both equal to 0. And our restrictions are that x is not allowed to be equal to -5 and +5. Okay, those are our restrictions. So now I'm going to think of, for the numerator, I'm going to think of 2 numbers that multiply to give me -20 and add to give me -1. So that would be -5 and +4. And we already know our bottom, or our denominator simplified. It would be x plus 5, x minus 5. And then we see, oh, well, these two cancel, right? They match exactly. So my simplified answer is x plus 4 over x plus 5. Now that plus holds all of this together. So I can't cancel out those x's because this is held together by that plus sign. We can only cancel out an expression if they match exactly, like x minus 5, x minus 5, okay? And this is our final answer because we didn't get either 5 or -5. All right, so then the last one, oh, I thought it was the last one, but anyway, so C, so if I brought that x in the front, so basically I'd have a -x plus 5. If I canceled out a -1, I would get x minus 5, right? So either way, it doesn't matter. But anyway, so I could get x minus 5 cannot equal 0. So I know that x is not allowed to be equal to 5. That's my restriction. So then I have x minus 5, and then I'm going to take this simplified version of -1 times x minus 5. Well, now that these match exactly, I can cancel these. So on the top, I end up with a 1. On the bottom, I end up with a -1. And 1 divided by -1 is -5. It's the simplified answer, which is okay because I did not get that x is equal to 5. So that is my answer. All right, let's try these 3. So my restriction is simply the denominator. So I'm going to, first of all, I can cancel out a y, or I can factor out a y, I should say. So y squared divided by y is y. 7y divided by y is -7 equals 0. So if this were 0, 0 times anything is 0. So y is not allowed to equal 0, right? If this were 0 times anything, I'd get 0. And then the other one is that y is not allowed to be 7. So my restrictions on letter D is y is not allowed to be either 0 or 7. All right. So let's now simplify it now that we know what our restrictions are. All right. So we're going to simplify. So the numerator is just y. Our denominator is y times y minus 7. And now these are both factors, so I can cancel out y divided by y is 1. So my final answer is 1 over y minus 7, which is fine because it doesn't just go against my restrictions. All right, moving on. All right, on letter E, there are no restrictions because the denominator is 6. There's no variable, so I could never turn a 6 into a 0. So letter E, the first answer is there are no restrictions because a 6 is not a 0. Not going to change that. And then if I simplify the numerator, all I could do is cancel out a -1. So I'd get 5x plus 4 over 6, which doesn't simplify. So either I would leave it in this form right here. This is the simplified answer. Or even if I wrote it like this is acceptable. These are equivalent. I just wouldn't need to do this because nothing cancels. So either the original answer is fine or this answer is fine. Either way, nothing simplifies and there are no restrictions on that one. And then letter F, my restrictions, I'm only worried about the denominator, excuse me. So I'm going to write my denominator. I want two numbers that multiply to give me 16 and add to give me 8. So that would be +4 and +4. Well, if I set both of these equal to 0, I could say that my restriction is x is not allowed to equal -4. So my restriction is x is not allowed to be -4, because then I'd get a 0 in my denominator, which is not allowed. All right, so then let's look at simplifying it, right? So my numerator simplified, all I can do is pull out an x, and I would get x plus 4. I already know what my denominator is simplified, which is x plus 4, x plus 4. And so these two cancel exactly. So my final answer is x over x plus 4, which does not go against my restriction, so we're good. All right, so that was 6R1. Let's look at 2.5. So what we're going to do is we're going to add rational expressions and subtract. We just have to remember that they need common denominators. It says to multiply, the first thing we're going to do is factor first, then simplify. When we divide, we're going to keep it, change it, flip it, then factor, and finally simplify. And remember, to find restrictions, all you want to think about is your denominator, setting your denominator equal to 0. So let's see what the directions say. It says step 1, simplify the expression. Step 2, determine what values of the variable must be excluded. That simply means what the restrictions are. So I like to start with the restrictions. So I'm going to look at just the denominator. And I want to think of two numbers that multiply to give me 32 and add to give me 12. So that would be, let's see, 2 and 16. How about 4 and 8? Yep, it's going to be 4 and 8. All right, so we have -4 and -8. So -4 times -8 is +32, and -4 plus -8 is -12, right? So first of all, we set both of these equal to 0. And then when we add 4 and add 8, we would see that our restrictions are x is not allowed to be equal to either 4 or +8. Those are our restrictions. Now that we know what our restrictions are, now we can simplify. So our numerator, we want two numbers that multiply to give us -24 and add to give us +2. So we need different signs, and the sign of the biggest number is positive. So that's going to be +6 and -4. So when we add them, there's our +2. When we multiply them, there's our -24. And then we've already simplified the denominator, which is z minus 8 and z minus 4. Since these match exactly, our final answer is z plus 6 divided by z minus 8. And that's our final answer. All right, so our restrictions is, let's look at our denominator. Y cubed plus 3y squared minus 54y. So we're going to factor out a y. And then we think of two numbers that add to give us 54 and, multiply to give us 54 and add to give us 3. So those would be +9 and -6. And don't forget about that y. So we have to set y equal to 0, which is 0. So y is not allowed to be equal to either 0, or if we subtracted 9, we'd have -9, or if we added 6 to both sides, 6. We have 3 restrictions this time. These are the restrictions: 0, -9, and +6. All right, let me get rid of this stuff. All right, so then we're going to simplify the numerator. We want two numbers that multiply to give us 45 and add to give us 14, which would be 9 and 5. And then our denominator was y plus 9 and y plus, minus 6. sorry, minus 6, right? So our y plus 9s cancel. So our final answer is y plus 5 over y times y minus 6. And that's our simplified answer. All right, so now we are dividing. So we're going to keep it, change it, flip it. So the first thing I'm going to think of, right up here, I'm going to factor this quadratic. I'm going to think of two numbers that multiply to give me 12 and add to give me 8. So that would be -6 and -2. And then I think I need two numbers that multiply to give me -16 and add to give me 6, which is going to be +8 and -2, right? Yes. So now I'm going to keep it. Change it to multiplication, and then I'm going to flip it. Y plus 2, and then y plus 8, y minus 2. All right, so since we're multiplying, we can simplify up and down and diagonally. So since this matches this exactly, those cancel. We get 1 and 1. And then our y minus 2's cancel. See that? So what are we left in the numerator if we multiply straight across? We have y minus 6 over y plus 8. And that is our final answer. All righty, so this is a multiplication problem. So first of all, let's simplify our numerator. Now this one's going to take a little bit of work because our coefficient of y squared is not 1. So this is when we're going to do the AC method. We're going to multiply 2 times -21, which is -42. So we need two numbers that multiply to give us -42 and add to give us -11. So that would be what? 42 divided by 3 is 14. So it's going to be 3 and 14. So we're going to bring down our first term. And we're going to bring down -14y plus 3y. Y'all agree that's -11y. And then we bring down our last one, our last term. So now we're going to factor by grouping. So we're going to bring out a 2y, and we get y minus 7. And then we're going to bring out a +3, and we get y minus 7. So our numerator simplified. Let me get rid of this. Our numerator simplified, come on, is 2y plus 3 times y minus 7. Okay, and now this numerator, we want two numbers that multiply to give us 8 and add to give us -9. So that would be -8, -1. So what do we have? Let me get rid of all this. So let's just write all of this down here, right? So it's plainer, more plain for us to see. We have 2y plus 3 times y minus 7 over y minus 1 times y minus 8 times y minus 1 over y minus 7. All right, let's see what cancels. So we have y minus 7 cancels, and then y minus 1 cancels. So basically what we have only in the numerator is 2y plus 3 times y minus 8. All right, so we could FOIL this and that would be a good answer, that's fine, or we can leave it in this form and that's our answer. So our denominator is 1, which we don't need to write, but that is our answer. All right, so here's some straight from your My Open Math homework. It says add or subtract the following rational expressions as indicated and simplify your answer. So we're not allowed to multiply, we're not allowed to add or subtract without common denominators. So to get a common denominator, basically we're just going to put these two factors together, right? So our least common multiple is x plus 1 times x plus 3. All right, so if we look at these as two separate terms, this is already half of our denominator. So basically what we need to do is multiply the bottom and the top by the other half, x plus 3, right? Well, 1 times x plus 3 is x plus 3. All right, and then the second term is we have half of our denominator, which is x plus 3. So now what we're going to do is multiply everything by x plus 1. X plus 1. So we're going to say minus x plus 1 in parentheses. So now we need to distribute that negative sign. So in the numerator, we have x plus 3 minus x minus 1. So we have in the denominator x plus 1 times x plus 3. So if we grouped them like this is what we would have. No, actually, that's not right. Sorry, I shouldn't have written those parentheses. So then in the numerator, we're going to distribute, we're going to combine like terms. So we have x minus x, which is 0. X minus x is 0. And 3 minus 1 is 2. So our final answer is 2 over x plus 1, x plus 3. And that is our final answer. All righty. All right, so let's look at this one. This is in your My Open Math. All right, so we have to have common denominators. Well, this, if we simplified this difference of squares, we would end up with x plus 6, x minus 6. So if we want common denominators, here is half of this, but our common denominator is going to be x plus 6, x minus 6. Well, the only thing we're missing here is x plus 6. So we're going to multiply the bottom and the top by x plus 6. And then this second term has both, so we don't need to change anything. So here we're going to distribute the 7 times x and 7 times 6. So we have 7x plus 42. This one doesn't need to be multiplied by anything, plus x minus 90. So now we can combine like terms. We have 7x plus 1x, and we have 42 minus 90. So 7x plus 1x is 8x. And then what is 42 minus 90? That would be minus 48 over, well, I'm not quite done because I see that I can factor out an 8 right here. So 8 factored out of both of these is 8 times x minus 6 over x plus 6, x minus 6. So I see that x minus 6 occurs on the top and bottom. So what is the final answer? The final answer is 8 over x plus 6. That's the final answer. All right, here we have a longer one. So the first thing I'm going to do is start with the quadratic. So I'm going to think of two numbers that multiply to give me negative 21 and add to give me positive 4. Whoops, I was about to write an x. Those are z's. So we're going to use positive 7 and negative 3, which happens to be half of both of those, right? So that's our least common denominator, z plus 7. z minus 3. So this part is here. What we're missing is z plus 7. Oh, z plus 7. We got to multiply the bottom and the top by z plus 7. The second term we're missing is z minus 3. And the last term, we're not missing anything, right? So we're going to multiply z plus 7 times z plus 4, z plus, why am I writing X? Z plus 4, and then we're going to do minus z minus 4, z minus 3, and then minus 6, right? So basically, when we write it this way, we see that z plus 7 goes away. And then it looks like z minus 3 goes away, but let's see, if we distributed that negative sign, let's see, we would do minus z minus 4, z minus 3. If we FOIL this, we would get z squared minus 3z minus 4z plus 12, and that's a negative. Let's see, so if we combine like terms, we get negative 7z plus 12, and then when we distribute that negative sign, oh, anyway, so let's see, two numbers that multiply to give us 12 and add to give us 7 would be z minus 4, z minus 3, but it's a negative, negative 1. Well, I'm going to go ahead and cancel these. And then that's still the opposite of z minus 4, right? So our denominator went away. So what do we have in our numerator? We have z plus 4, minus, so if we distribute that negative sign, we'd have minus z plus 4, and then negative 6, right, over 1. So z minus z is 0. And then we'd have 4 plus 4 is 8, and 8 minus 6 is 2. So our final answer is 2. Wow, that was a lot of work, you guys. That one was a little confusing. So when you have that problem, if you're working and you have that problem and you need some help, please reach out to me. Make sure you join me for class either Tuesday night or Thursday night, and I'm sorry, Wednesday or Thursday. All right, guys, and I will see you for class time. I hope that helped. You guys have a great week, and I will talk to you later on.